Hi guys, this is Mrs. Cerami back with 9.2. We're going to be discussing binomial theorem and Pascal's triangle, both concepts which you did go over in Algebra 2, and again, which is the next part of our curriculum, so we are moving forward. Let's start with a much needed quote. I can do all things through him who strengthens me. So write this down, keep looking at this quote. We've got this, guys. All right, before we go into the lesson of 9.2, let's do a review of why it's important. If I wanted to do this operation, the quantity of a plus b to the 0 power, I would get 1. Oh. Okay. All right, I would get 1. Now, a plus b to the first power. Anything to the first power is itself, so I'm just going to put coefficients in front of it. Normally we don't. It's 1a plus 1b. A plus b squared, we know the formula is going to be a squared, so 1a squared plus 2ab plus 1b squared. If we were to multiply this out, it would take a little longer by hand if you didn't know the formula. We're going to get 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. And if we were to multiply this out, it would take such a long time. And this would take a long time. I won't even have you guys do it. So how do we get these answers just by not multiplying it out? Well, the first method we could use is using Pascal's triangle to get the coefficients. So we're going to skip this for a minute. Actually, we'll go to this, the binomial theorem. So binomial theorem, as you can see here, it has all of the binomials to the nth power that I had on the previous slide. And I can write all of this out without doing any work using the binomial theorem. How do I get that? Because again, we've got the 1 here and the 1 here. How do I get that? Well, Pascal's triangle are the coefficients from the previous slide. So this was our to the 0 power 1. This was the 1a plus 1b. This is the 1a squared plus 2ab plus 1b squared. These are all the coefficients here. And again, coefficients are the numbers in front of the variable, so that would be the coefficients of our answer. So if I wanted a plus b to the 4th power, we would get 1a to the 4th plus 4b a cubed b plus 6a squared b squared plus 4a b cubed plus 1b to the 4th. We're going to talk on the next slide or two how we come up with the variables, but the coefficients are straight from Pascal's triangle. Now, how do we get Pascal's triangle? Like if you wanted to create that on your own. So what you're simply going to do is you start with 1 on top, the pyramid. And you're going to have 1 on the sides. If you look, all the exterior rows have 1s. The next row, once we put our 1 down for the outside, is the sum of the two numbers above it. 1 plus 1 is 2, and there's nothing else to add. You put a 1 here. Put a 1 on the outside. 1 plus 2 is 3. 2 plus 1 is 3, and we put a 1. There's nothing else to add. Put a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and you put a 1. As you can see, there's lots of symmetry. Once you have one side, we'll know the other side as well. There's other patterns with Pascal's triangle, but we only really care about right now the rows because it's going to dictate the coefficients for us. One thing I will stress is that the second position is the coefficient. So if we wanted a plus b raised to the 5th power, we would use these coefficients here. If we wanted the 2nd power, we use this one. Okay, so the second one is the coefficient. If we wanted to add another row, we put a 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And you can see the symmetry, and then you have a 1 again. And we can keep going. So now you guys hopefully remember from last year how to devise Pascal's triangle. All right, now, how do we use it? We just want to write the coefficients down now, not the actual standard form. So the exponent is telling me it's a 5. I go to the second term. Here is my 5. This is my 5th row. So therefore, I am going to write the coefficients as 1, 5, 10, 10, 5, and 1. These are my coefficients, which we will combine with variables in a little bit. If you're wondering how this could be the 5th row, this is the 0th row. If you remember, we got this by 2 to the 0 power. Find the coefficients. So again, we're not solving yet. Of the 4th term of x plus 1 raised to the 5th power. So 5th power, this is our 0 row, 1, 1. This is our first row, 1, 2, 1. This is the second row, 1, 3, 3, 1. That's the third row. So just so you're not confused, these are the rows. We're going to keep going until we get a 5 in the second position. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. All right, here we go. There's the 5th row. So these are the coefficients. We want to find the coefficient of the 4th term. First term, second term, third term, 4th term. So the answer would be 10. If I knew how to draw a pirate, there you go. Does that look like a pirate to you guys? There's the 10th term. Find the coefficient of the second term of x plus y to the 6th power. So again, this is great practice for Pascal's triangle. We're going to keep going until we have 6. I'm going to keep going. This is 5. And we have 1, 6, 15, 20, 15, 6, 1. Here we go. Find the second term. So the second term is this guy here. So the answer would just be 6. Again, you can pause this at any time and just look for the answer. I'm going to go through all the details though. So again, Pascal's triangle, 1, 1, 1. I'm going faster now because I think you guys hopefully remember from last year. Even with my quick review, I think you hopefully have the gist of what to do to write this out. So we're just going to add one more row. And if this was in class, I would have kept this on the whiteboard and I wouldn't have to keep rewriting this. But it's good practice. So this is the 7th row. We want the 5th term. 1, 2, 3, 4, 5. Here we go. The answer is 35. Now we want to simplify this. So simplify means we want it in expanded form. So the first thing we're going to do is we're going to find the coefficients. So it's the 3rd row. So row 0, row 1, row 2, and now we're at row 3. So these are going to be my coefficients of the term. We're going to have 4 terms. We're going to have 1, 3, 3, 1. Because this is an addition here, we're going to be adding all the terms because it's an addition. Now, variables, what do? Well, you're going to go in descending order for the first term and ascending order, meaning you're going up for the second term. So the first term is going to be 1x cubed, and this is really y0, which is just 1. Now we're going to go down. X squared, x to the first, and x0, which is 1, which is not existing. I like to then go from the right. This is the right term. I like to go from the right. And we're going to go y cubed, y squared, y, and y to the 0. So again, you're going ascending with y's. 0 to the first, to the second, to the third, and descending with x, cubed, squared, 1, and 0. We're going to do a bunch of these simple examples today, and tomorrow we'll amp it up a little more. All right, so this one here, Pascal's triangle. So again, you can either have it in front of you or you can keep rewriting it. When we get back to school, you will be tested on all this, and writing Pascal's triangle will be one of the concepts that I will be testing you on. All right. So we have 20 here, just so you can see where everything's coming from. And now 15, 6, and 1. So my coefficients are going to be 1, and we're going to, again, x to the 6th power. And now 6, x to the 5th. We're going to have 15, x to the 4th. 20, x cubed. 15, x squared. 6, x. And then 1 is the last coefficient. As far as the y's, this is y to the 0, y to the first, y squared, y cubed, y to the 4th, y to the 5th, and then 1y to the 6th. The only thing left is to put the operation in. So we are subtracting here now. So if you subtract and you have an odd exponent, you're going to have negative. Here we have an even exponent, so it'll become positive. So what you're going to do is you're going to keep alternating with subtraction. Addition, it's all addition. With subtraction, you alternate. And this is your final answer here. Hopefully in one line. We're going to do one more problem. So it's to the 4th power. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is the row we want. So we're going to have 1, x to the 4th, 4, x cubed, 6, x squared, 4x, and then we're going to have 1 here. Now this gets a little tricky because you're going to have 2 to the 0, which is 1, 2 to the 1st, 2 squared, 2 cubed, and then 2 to the 4th, which is 16. And they're all addition. So there's one more thing you need to do. We have to simplify. So this is going to give us x to the 4th. 2 times 4 is 8, x cubed, plus 24x squared, plus 32x plus 16. This is your final answer. All right, keep looking at my videos back and forth. If you have any questions, message me. I will have my math lab for you to do, and then you're going to have a few problems due Monday night where it's a little bit harder than this, but if you've got this, you'll rock that as well. All right, hope you're having a good day. Bye.